Welcome, Professor Nandita Goyal, from on behalf of SCRT Director SCRT. I welcome you.
Thank you. Thank you so much, sir.
Good evening, all participants. This is the program by SCRT Haryana Gurugram, and this is a special. We are paying thanks to Professor Nandita Goyal, who agreed to deliver this talk today in the evening. And our participants, those who are TGT or PGT, they are teaching mathematics in their classes from 9th to 12th and even 6th to 8th also. But they are nowadays, for the last 2 days, they have joined this program for Vedic mathematics. The government of Haryana has given a special initiative for organizing this, means promoting Vedic mathematics to the school. So this year, last year also we tried, and we have conducted a training program with mathematics teachers. But this year we again started, as government of India is also promoting this program. So it is sponsored by the MHRD, now known as Ministry of Education, and also the state government is also in favor of promoting the Vedic mathematics in the schools. So this year we are going to organize this program for 3 months continuously, and in this 3 months program, every week around 80 participants will be dealt with, and they will be uh, attending this program, and they will be given the way how to deal mathematics using Vedic mathematics, how different approaches can be used, and also how these can be used for competitive exams like NTSC or IIT or other Olympiads also. So my colleagues, Mr. Rakesh Bhatia and Mr. Maruti Sharma, Deepak Vashisht, and many other renowned uh, people, those who are working in this program and acting as a resource persons. So this is here. So I am here to welcome Dr. Nandita Goyal, and I also now share the mic to Mr. Rakesh Bhatia, who will just talk about Dr. Nandita Goyal, who will welcome and just introduce Dr. Nandita Goyal, please.
सर आपका माइक ऑफ है राकेश सर।
ओके ओके, थैंक यू डॉक्टर साहब, और आपका बहुत बहुत धन्यवाद। फर्स्ट एंड फॉरमोस्ट मैं डॉक्टर प्रोफेसर नंदिता गोयल को वेलकम करता हूं और इस हरियाणा की इस कर्म भूमि पर, और उनका स्वागत है। एंड शी इज वेलकम्ड बाय द SCRT एंड गवर्नमेंट ऑफ हरियाणा। और इस प्रोग्राम में हम लोग जो वैदिक मैथमेटिक्स के बारे में बात करेंगे, वो आज की सोर्स पर्सन और हमारे चीफ गेस्ट प्रोफेसर नंदिता गोयल, एंड शी इज वर्किंग वेरी हार्ड टू elaborate and to spend and or to share the Vedic mathematics in the USA and all over the world. And I'm very happy to know about Professor Nandita Goyal, that she is very keen interested to learn more and more, and she is keen interested to explore more and more. So we are so lucky that the percentage like that Nandita Goyal is expanding this knowledge, and we are all lucky that we will today listen her thought about Vedic mathematics. Professor Nandita Goyal is academic track in mathematics, and she is a gold medalist in mathematics, physics, and electronics. And she has held a Master's of Science in Mathematics, Master of Philosophy with distinction in Applied Mathematics, and a Bachelor of Education. So she is teaching mathematics in New Jersey since the last about 15 years. And basically, she belongs to India and Punjab. And but after her education, she is working there in USA, and she is very industrious and very intelligent, and she is keen interested to spend and to expand this knowledge. तो मैं सबसे पहले वेलकम करना चाहूँगा प्रोफेसर नंदिता गोयल का, और ताकि जो है वो हमारे बीच में आज जुड़ी हैं हरियाणा के टीचर्स के साथ, और अपना मेंटलिटी, अपनी थिंकिंग, अपना नॉलेज शेयर करने के लिए। तो मैं स्वागत करूंगा, और मिस नंदिता गोयल जो है वैदिक मैथमेटिक्स से लगभग पिछले 1 साल से जुड़ी हुई हैं और इसको वैदिक मैथमेटिक्स को फैला रही हैं। तो प्रोफेसर नंदिता गोयल, आपका बहुत बहुत स्वागत है इस SCERT हरियाणा द्वारा। और प्रोफेसर सुनील बजाज, डॉक्टर सुनील बजाज जो डिप्टी डायरेक्टर हैं अपने SCERT गुड़गांव में, और HOD हैं मैथमेटिक्स डिपार्टमेंट की, एंड उन्होंने भी आपका जो है स्वागत किया है, और बहुत उन्होंने खुशी का इजहार किया है कि ऐसे ऐसी परिस्थिति हमारे बीच में जुड़ी हैं। तो हम सब जो है आपके सुनने के लिए सब आतुर हैं। तो नाउ आई इनवाइट प्रोफेसर नंदिता गोयल टू डिलीवर योर स्पीच।
Namaste all, and good evening all to my professional counterparts. By professional counterparts, I mean my brothers and sisters by profession. So first of all, I would like to congratulate Dr. Rishi Goyal, Director, and Dr. Sunil Bajaj, Deputy Director and HOD Maths of SCERT Haryana, to organize this teachers training program. It is my immense pleasure to be part of this online workshop today. I would like to express my gratitude to the worthy organizers for inviting me and giving me this opportunity. I would also like to thank Shri Rakesh Bhatia ji, Vedic Maths expert, Board of School Education Haryana Bhiwani, National Co-Coordinator from Shiksha Sanskriti Uttanyas, who is working tirelessly to coordinate these workshops. Thank you, sir. I am delighted to share this platform with you all, learned participants and worthy guests. And I look forward to sharing my experience and journey of Vedic Maths with you all. Myself, being a staunch believer of Vedas and student of mathematics throughout my life, hopefully I'll be able to share some insight about Vedic mathematics with you all learned participants. So the topic which has been given to me today is to discuss the power of Vedic mathematics, unlocking our ancient wisdom with you all. And myself, as Shri Rakesh Bhatia ji has mentioned, my name is Nandita, and I belong to India, and I work here in New Jersey, USA. So again, would like to thank you all for listening to me, for sparing your time at this moment, Saturday evening of yours, so that time could be coordinated between us, and it is very early morning I won't say in USA here, so that we could match the time. So thank you for, giving your time to me. Now today, as you all are mathematics professional, I'll be in brief, talking about which you all know what is mathematics and where is mathematics in Vedas, and generally what is Vedic mathematics, its scope and its goals. So here, as we all know, mathematics is fundamental and useful, and to know what is happening around the world in day-to-day life, it is important that we know about mathematics. We learn, and we pass it on to the next generation. Now, many a times you must have also come across with the question, why do we need to learn math? It is so hard. And then you can give this answer, which I used to give it to my students, whether it is from anywhere from the world, that it is language of the universe. Better you are at it, further you can go with it. Then there will be no boundaries, there will be no borders which can separate us. It is satisfying. So when you have understood, which nobody else has understood before, it is so much gratifying and it is so much satisfying. So that's why one should learn math. It creates many job opportunities. So as you know, many a times we are asked, take math, whether you are taking sciences, whether you are taking arts, whether you are taking commerce or any other field, take math. It will open up many options for you in future. So it creates many job opportunities. It prepares you for life. I know you must be more experienced than me. Some of you might be new in this profession. Many a times we tell students, life is not simple, so do the problems. So it tells us how to handle life, how to handle problems. It's hard. I come across this phrase many a times in my life. Whenever I see a new set of students, it is hard, but I tell them it gets interesting once you get it. So it might be hard for you. So when I look at a painter, I think how do things come in its mind and how do that person paints so well. So it's the same thing. You have to just get interested in this. Once you get interesting, then it becomes easy for you. Now, another question which I come across is, we hear there is science in Vedas, there is mathematics in Vedas. Do you have any reference to that? So I will just quote one small reference, and there might be many more, that even the Shanti mantra from Yajurveda discusses the concept of infinity, Purna, in mathematics, and in fact states that when Purna is subtracted from Purna, the remainder is still Purna. And the mantra goes like this: Om Purnamada Purnamidam Purnadam Purnamudachyate Purnasya Purnamadai Purnameva Vashishyate. So nothing is, when you subtract Purna from another Purna, still what is left is Purna. So there is a reference of mathematics in Vedas. This is just one small example. And even if you see, even in the Shukla Yajurveda, the Shatprak Brahmana text, it talks about Pythagorean theorem, the value of pi, geometry, astronomy, planetary distances, etc. as well. Now, let's talk about Vedic mathematics. Who is father of Vedic mathematics? We all know, we all have seen his picture, but let's know how did he, create this Vedic mathematics. So the revival of Vedic mathematics is no less than a miracle, extracting the theorems and corollaries from religious texts require not only an understanding of the scriptures, but also a genuinely intelligent mind. And let me share this thing with you. Who would do it better than Swami Bharti Tirath Ji? Because he did masters at the very, very young age in 6 subjects at the same time, and he topped in all those 6 subjects. So you can understand the intelligence quotient of this person. Jagat Guru Swami Bharti Tirath Ji, Maharaj Shankaracharya of Sharda Peeth and Govardhan Mutt had discovered 16 sutras and 13 upsutras in the Parishishta of Atharvaveda, which we call Parishishta, which we call as appendix of any text. This he achieved through rigorous tapas and transcendental meditation, which he did in the forests of Karnataka. Through sheer intuition and scholarly pursuit, he was able to decode them and get wide-ranging mathematical principles and applications from them. So I see light at the end of the tunnel when I read this, that if he can, decode those sutras from our ancient texts, yes, that he definitely did rigorous tapas and transcendental meditation. But that means we can also get into it, we can also get involved, and we can also find some of the amazing things from those texts. He found that these sutras covered all aspects of modern mathematics. Yes, you are hearing it right. It covered all aspects of modern mathematics. Now, many a times, I see a lot of, videos, I see a lot of, institutions or a lot of people, they talk, sometimes give credits to Vedic mathematics. Sometimes they just call it, oh, I am going to tell you a trick to do this easily. But yes, wherever we refer to, we should always give credit where we are taking it. And I also want to clarify one thing, which is a misconception about Vedic mathematics, is these are not only bunch of tricks. Please, those whosoever tells you that these are tricks, please correct them, that these are not only bunch of tricks, but as Swamiji has very rightly said, that these are one-line solutions to the mathematical problems. So yes, you heard it right. You can do most of the mathematical problems in one line. There are algebraic and numerical proofs to these sutras. So it is not just vague, it is not just made in the mind, and these are not just bunch of tricks, but I would call it mental math, which help you solve any problem in lesser number of steps. Now, the scope of Vedic mathematics in different branches, whether it is pure or applied, is unlimited. To name a few, here is the list. So whether you talk about arithmetic, algebra, geometry, problem solving, trigonometry, conics, astronomy, calculus, coding, or some applied parts, work, projectiles, forces in equilibrium, etc. Now, what are the benefits of Vedic mathematics? I know you teachers being so busy with your school part, job, and yes, we all have our family lives as well. What is the purpose of learning this, Let me tell you, the benefits are enormous. I would call it organic. Organic is so much in, this word is so much in these days, right? This is natural. This is original, this is unconventional, this is far away from traditional methods, yet this is simple and direct. It increases speed in mathematics and promotes interest. So it reduces basically memorization, because then you understand what you're doing, why you're doing, and then it increases your speed, which is very much required in competitive exams or some Olympiads. It improves math knowledge by showing clear connections between different branches of math. Hence, it helps in developing proofs. Mental calculations stimulate development and improves memory. It improves mental abilities. It provides an alternate way to perform or to check calculations and result, and we call it Bijank method or digit sum method. It integrates two hemispheres in the brain, hence helps in holistic development. It helps in spiritual development, hence reduces stress and anxiety. Now, there have been many researchers in USA who have used Vedic maths as a part of their research in various fields. To name some, I have Stewart Dixon and Himanshu Thapliyal, who have used Vedic mathematics in their researches. Now, there are various institutions in USA who have been promoting Vedic maths here as well. To name, Vedic Sanskriti schools all over USA are imparting knowledge of Vedic mathematics along with other Vedic literature to Indo-American community, especially to Indo-American kids who do not have much bonding with India, but their roots are there because their parents or grandparents belong to India, and they definitely want their kids to know this, wisdom. Various Vedic Samajas, Arya Samajas, are also promoting Vedic mathematics in USA. Vedic Vidyalaya, the School of Language, Arts and Science, is teaching Vedic mathematics as one of many subject areas taught. Math Monkey, another supplemental math program, there are 5 branches in USA, which is also teaching Vedic maths. Mercy School, Iowa, USA is also promoting Vedic mathematics here. And the latest good news is one of the university, the professor, Dr. Kapoor, is also thinking of pursuing this under his guidance here in USA. Now, what is scope of Vedic mathematics? Many times you will also come across, when you will pass this knowledge to your students, you will also come across this question, what is scope of Vedic mathematics? So you can say whether it is technology, electronics and communication, astronomy, cybersecurity, research, or employment, it will help you in all these fields. Now, why we have gathered here together? That we should share some common goals and we can work towards promoting Vedic mathematics. So the first goal I would suggest here is Vedic mathematics integration into mainstream education is required not only in India, but in other countries as well. So we should not only take it as, a separate course or, supplemental course, we should actually incorporate it in our mainstream education. It is the high time to amalgamate modern education with Vedic education so that the benefits are vast. To make next generation, who better than you all, we all, can make next generation more interesting in Vedic maths? We need to blend the strong conceptual understanding with its application in different fields. So we need to address that and we need to pass it on to the next generation. Now, I'm going to share some topics which you might be interested, and you can take it forward as you want to. And I know there are so many intelligent minds sitting there listening to me, and you never know, you can make it so interesting, you can make it so creative that we come across something new. So first is, let's see, how can we find cube of a number? As you can see, the application of it would be how to find the volumes of cube. And many a times you can also apply this in finding compound interest. So applications are enormous. Here we are going to discuss only the base, how to find cube of a number. So I'm going to use Nikhilam Navta Charamam Dashta Sutra to find the cube of a method. In short, we also call it base method. So base method means if a number is close to the base, how can we find the cube of that number? And the number here I've taken is 106, and I want to find its cube. Now, you will see that I will be showing you multiple steps here to reach to the final answer. This is just the process which should be there in your mind when you are calculating it. So once you understand it, that all the steps you can do it in your mind, and then you can just write your answer in 1 or 2 steps. So if you see, the base of the number 106 is 100, and how far it is from the base, we call that term as deviation. So the deviation is 6 and the base is 100. And then what is the technique? What is the formula we are going to use? Is either you can say this formula or this formula. Now you will ask me which one to use. So whichever formula you are comfortable with, you can use that. I personally use this one, but that doesn't mean that you are not, you cannot use the other one. So whatever formula you're comfortable with. So here what we do, we start with the base, we add 3 times of the deviation, then second step, 3 times of the deviation square, and the third step is the deviation cube. Or you take the number, which is 106 itself, and add 2 times the deviation. Second step, 3 times the deviation square, and the third step is deviation cube. So basically there is only difference in the first step if you use the first method or the second method. So here, the base is 100, 3 times the deviation is 6, so 3 times the deviation. Then the second step is 3 times the deviation squared, and the third step is deviation cube. Now, if you see 3 times 6 is 18, so 100 added to 18 will be 118. 3 times 6 square is 108, and 6 cube is 216. You might have noticed that I have written the 100 terms of the second and the third step tiny and the bottom left. That is for a reason. Now, if you notice how many zeros are there in the base, there are 2 zeros in the base. So that means from the extreme right, which is 216, we will take 2 digits, and if there is any other digit in front, we will carry it forward. We will add it to the next number. And the same thing we will do with the second step. So that's how you will add it to the next number. So that this 2 will be added to 108, that will become 110. And then that one you will be added to 118, and that will become 119. So what is the number? Then you will just copy the numbers down. So 16 from here, you will copy it down. 8 plus 2 became 10, you will copy it down. 118 plus 1 became 119, you will copy it down here. So the final answer will be 1191016. So I hope you have understood this. Once you practice this couple of times, you can do most of the calculations in your mind, and then you can write your answer in 1 or 2 steps. Now, I would request you all to try doing this one and see whether you get it or not. So I have written the formula, I've written the base, I've written the deviation in front of you, and try and see whether you get it or not. Okay, I have Ravinder Kumar ji who have given the answer. Let's verify. Sunita Devi ji who have given the answer. Very well. Very nice. So many teachers over there are trying it and giving the answers. So let's verify. So yes, the base here is 1000 and deviation here is 5. So we will use it in the formula. And this is what you will get. Now, if you notice, there are 3 zeros in the base. So we will have 3 digits in step number 3 and step number 2. We will keep all of them. There will be nothing which will be carried forward. And your answer will be 1015075125. Now, the next thing is, if the number is little less than the base. So we have taken the example before when the number is little higher than the base. So when the number is little less than the base, even then we use the same formula. The only difference there would be the deviation would be negative. So let's see how to do that one. So base here is 100 and deviation here is -2. And we are using the same formula, base plus 3 times the deviation. Second step, 3 times the deviation square. And the third step is deviation cube. So 3 times -2 is -6. So 100 take away 6 would give you -94. And this 3 times -2 square will be a positive number, which will be 12. And -2 cube will be a -8. Now you must be having a question that how to handle this -8 number, right? So if you have heard about Vinculum numbers, you can apply that. Or if you have not heard about Vinculum numbers yet, then you can also simply consider it as you are subtracting, this is 12, this is 0, 0. So 1200 take away, let me write down here. So basically what you're doing here is I am representing this -8 as bars at the top because I'm using Vinculum concept. And since there were two zeros in the base, so I need to write 0 in front to make it 2-digit number. So 08. So what is basically done here? Basically you are subtracting 8 from 1200. So this is what you're doing, because don't forget this was -8. So that means you have to subtract 8 from whatever the number you're getting. So basically this is what? 1200 minus 8, which will give you 1192. So if with these two steps, what you get? 1192. So your final answer will be 941192. So we can also use the same method if you are finding sum of the cubes. So sum of the cubes or difference of the cubes, you can also find the same formula, but you have to adjust accordingly. So here I have taken example of sum of the cubes. 1006 cube plus 1010 cube. So you don't have to find them separately and add them at the end. What you can do is you can handle them together by using this formula, which says base 1 plus base 2 plus 3 times deviation 1 plus deviation 2. That would be your first step. Second step would be 3 times deviation 1 square plus deviation 2 square. And the third step would be deviation 1 cube plus deviation 2 cube. So if you connect this formula with the original formula, this is very close because we were finding sum. That's why it is you are adding d1 and d2. You are adding d1 square and d2 square, and you are adding d1 cube and d2 cube. So now our base 1 is 1000 and deviation 1 is 6. Base 2 is 1000 and deviation 2 is 10. So you can try doing this and see what you get at the end. So just plug it in and see what you get. I'm so happy to see so many enthusiastic participants. And, trust me, even I used to get interested the same way as you are getting interested. It was so much of wow moment for me when I learned and when I used to apply it. So it is so much wonderful. I hope I'm at the right pace. I'm not too fast or I'm not too slow. Very nice. There are many people who are answering. Okay, let's see. So this is how we will plug in the numbers. And since there are 3 digits, 3 zeros in the base, 1000 is the base. So keep that in mind. We will have 3 digits. And if there is any 4th digit, we will add it on to the next step. Like this. And this would be your final answer. Very well, very well. Now, moving on to the next example. So you must be thinking, okay, we got it, when the numbers are, very close to the base, whether it is little high or little low from the base, we can apply this formula. What if the numbers are far from the bases? Is there any other formula which we can use? The answer is yes, you can use another formula. And let me tell you, we are just getting to know a little, and the scope is unlimited for you to go further, to do the research and to get your answers. And let me tell you, it will be so much satisfying that you are discovering something which is already there, and you're going to find something new. So the next method for that, which is called ratio method, we have used the Upsutra, which is Anurupin. Anurupin means proportionally, by proportion. So this is called ratio method. As I've told you, if the numbers are far away from the basis, then you can apply this method. I'm going to share some examples with you, and the rest, the world is with you, and you can explore, expand, and create whatever you would like to. So here, the number whose cube I'm going to take is 13. And there are 2 ways of doing it. Either you go from left to right. So I'll show you the problems from left to right. And the last problem which I'll take, I'll also show you the same problem, how to do it from right to left. So again, the answer is which one is better, which one to use, whatever you feel comfortable, whatever you think you can do it faster. So left to right. So that means we will use the formula left to right like that, which is a cube r, a cube r square, a cube r cube. So now we have to define what do we think as a and what do we take as r. So a, since we are going from left to right, so the first digit will be considered a, and the ratio will be taken in the opposite manner. So this is the important thing which you have to keep in mind. I repeat, if we are using left to right method, the first digit will be a, and the ratio will be taken from the right digit to the left digit. So ratio here is 3/1. So r is 3/1. So now once you have figured out you are using left to right, that means you have figured out a, you have figured out r, then the only thing is you just need to plug it in. So I'm plugging it in. A cube is 1 cube. A cube r is 1 cube times 3. This way I have plugged in all the values, and what I get is 13927. Now we need to have the coefficients. We need to multiply it with some numbers, and then those numbers are 1, 3, 3, 1. So we will multiply vertically 1 with 1, 3 with 3, 9 with 3, 27 with 1. Now you will ask from where this 1331 is coming. So you all know what is a plus b cube, correct? We all know what is a plus b cube. So here 1, 3, 3, 1 are coming from the coefficients, because if you notice closely, we are using the same formula here. Instead of b, I'm writing r, I'm taking ratios. So a cube, a cube r, like that, we will be using the ratio. So it's the same thing, but we are using in terms of ratio. So don't miss the coefficients out. So that's why we are writing 1, 3, 3, 1, and we are multiplying them vertically. So when I say we are multiplying them vertically, so 1 multiplied with 1 gives you 1, 3 multiplied with 3 gives you 9, 9 multiplied with 3 gives you 27, 27 multiplied by 1 gives you 27. Again, how many digits we need to keep? So we know that the base is 10, so we should keep one digit, and whatever the number is, other digit, we will have to bring it forward, carry it forward. So same thing here, carry it forward. So that's why whatever carry numbers are, I try to write it down. That's so that I do not get confused and it is clear which numbers need to be carried forward. So what is our final answer? Our final answer is 2197. See, when I learned all this, probably the first time there were many questions, there were many whys, there were many ifs, but trust me, if you go back, review, and try doing more, it will start talking to you itself. It will start making sense to you itself. So please, go further, go beyond, and discover it. Yes, somebody has written Meru Prastar. Yes, you're absolutely right. Yes, we are using Meru Prastar. Yes, binomial theorem is extension of Meru Prastar. Correct. Thank you. Thank you for bringing it up. So, shall I move on? Okay. Now, I have compared, with right to left method on the right and left to right method on the left. So left to right I've discussed in detail. Now I'm going to briefly discuss right to left method. As I told you, right to left, my starting point is the right digit. So A is 3 in this case, and the ratio would be from the opposite side. So ratio here is 1/3. Now, instead of using a cube r, I would be using in reverse now, a cube r square, a cube r, and a cube. I will get the numbers. The coefficients would be the same, 1, 3, 3, 1, and the answer would be the same, 2197. So I'll hold on this slide so that you can note down the right to left method as well. And whatever method you find you are comfortable with, you can use it from left to right or right to left. If you can just show me thumbs up so that I can move to the next slide, that would be great. Anyone? Okay, perfect. Thank you. Now, and one more example, and I want you to try this on your own now. So if you have to find 44 cube, wow, somebody has already given the answer. I'm so delighted, so happy. Isn't that so interesting, all of you? I got so engrossed when I got introduced to this mathematics. I think you will also get engrossed with this. Thank you, everyone who are all answering. Wonderful, wonderful. Should I show you the answer? Very nice. Thank you, Dharamveer ji. Thank you, Mandeep ji, Satpal ji, Manisha ji, Sonia ji, Sushma ji, Sunita Devi ji, Dinesh Bhatia ji, Anil Kumar ji, Janak Kumari ji. I might not be able to take all the names, but thank you, everyone, whosoever is participating. So, these are all the steps. You can see, you can look at it, and you can match, you can tally whether you get it right or not. Most of you, I would say everyone has given the right answer. Wonderful. So you know what, many a times what you can do is you can also give the same concept as puzzles to your student. So you can just take away one digit and put a blank or put a letter for that and tell your students to finish it so that they rethink the same thing in reverse pattern. So that's what I'm telling you. This is just the beginning. This is just the initiation. And what you can do with it is all in all of your hands. What you can create with this, it could be a new magic. Then another concept I'm going to take is algebraic division. So many of you must have handled this before, since, as I before told you that you might be more experienced than I am, you might be new in this profession, but I think whatever we hear, whatever we listen, sometimes it creates, eureka moment for us. And I was like, oh, we could do it this way as well. And it is so much easier. And what the next thing we think is, oh, I'm going to use this in my class. It would be so much beneficial to my students. And that's the whole purpose of being here and exchanging our ideas. So let's see algebraic division. Now, the sutra used is Paravartya Yojit, which means transpose and apply. Now, I'm sure I'm going to do this problem and I will see many responses that you know how to do it already, and I know you know how to do it already. But my objective is to start with this and take you further, and then you will see that, okay, we can do much more than what we already know with this method, with this Vedic mathematics method of dividing a polynomial with another polynomial. So I'm going to take 4 examples. So let me tell you. So first example is a linear polynomial with leading coefficient 1. So leading coefficient 1 here means, so when the divisor is linear, that is my first example, first problem I'm going to take. So here divisor is linear, as we all know, and the leading coefficient here is 1, as we all can see, right? So this is my first problem I'm going to take, and I'm sure you all know this. Any idea, any guesses what I'm going to discuss? what you know or what I knew before I knew about Vedic mathematics, I called it synthetic division method or Horner's method of dividing. But let me finish this and then I'll come back to how it is different from synthetic division, or how it is an extension, or they have used it for synthetic division and then we can further apply it in other situations as well when the divisor is different from being linear with leading coefficient 1. So here divisor is x plus 2, as we clearly know. And what do we define deviation? Same thing, the same deviation trick, not the trick, the same deviation rule which we have used in cubes, how far that base is, the number is from the base. So here if I take base as x, how far x plus 2 is from x, that is x plus 2. So here, this is the complete solution, but I will explain you step by step. So divisor here is x plus 2. Deviation here is positive 2 because it is 2 units away up from x. And transpose means you take its opposite. So whatever is the deviation, you take its opposite. So that is negative 2. So now I will take negative 2 here and I will write all the coefficients in the descending exponents of x here as the first row. So first, please make sure that this polynomial is in standard form. It is in descending order of the exponents of x. So I will copy the first digit as it is. Then I will multiply crosswise. So negative 2 times 3 will give you negative 6. I will write it under the second column and then I will add them vertically. So adding them vertically gives me negative 1. Now I will multiply negative 1 by negative 2. It will give me positive 2. I will write it under the third column and then I will add them vertically. So negative 3 added to 2 will give you negative 1. Again, I will multiply negative 1 with negative 2. I get positive 2 and I'll add them vertically and I'll get 6. Now, you must be seeing I am having a demarcation here as a dotted line. Why do I have it here? Since my divisor is linear, so starting from the extreme right, I will have a demarcation after one number, one digit here. So what is the purpose? Because whatever is after this line will be the remainder and whatever is before this line will be the quotient. So I repeat, since my divisor was linear, so that's why I have a demarcation line from the right side after one place of the digit, and then whatever is after this line will be the remainder and whatever is before this line will be the quotient. So now degree of the dividend polynomial is 3, degree of the divisor polynomial is 1. So definitely degree of the quotient polynomial will be 1 lesser. So the answer is 3x squared minus 1x minus 1. This is your quotient and your remainder is 6. Do you get it? And I know that most of you know this by synthetic division method. Now, since if you remember when I was discussing that, what are the benefits of Vedic mathematics, I talked about Bijang method. Since I talked about Bijang method, it could be one complete lesson on that, trust me, but I will certainly, introduce you what I meant by that Bijang method. I will just introduce you here. And then, probably in the next sessions, you can ask one of your mentors to explain about Bijang method more in detail, okay? So I hope these steps are clear. And then how we can verify. Bijang method is very, very good to verify our answers. Many times we tell our students, before handing over your exam, review your work. check your answer. And there, this method would be so much handy, not only in division, in so many ways, in so many other mathematical problems as well. So we know, all of us, we know this remainder theorem, that divisor times quotient plus remainder is dividend, right? So now here with B, I'm talking about Bijank of divisor times Bijank of quotient plus Bijank of remainder equals Bijank of dividend. So what do I mean by Bijank? Listen here. Bijank of the divisor. So divisor here is what? This. So what is the coefficient here? 1. And what is the coefficient here? Plus 2. So 1 plus 2 is 3. So that's what I have it here. That is Bijank of the divisor. Then quotient. What is the Bijank of the quotient? Quotient is here. So 3 minus 1 gives you what? Positive 1. So that's what I have it here. That is Bijank of the quotient. Then remainder. What is Bijank of the remainder? It is 6 only, 6 itself. So 6 here. So then Bijank of the dividend. So dividend is here, 3 plus 5 minus 3 plus 4 gives you 9. So I have everything here. Now the only one step away is, does it verify? So 3 times 1 plus 6 is 9, hence verified. So isn't that beautiful? So just by using, digit sum, you can actually verify whether you did it right or not. So for example, let's say you made a mistake in calculating the remainder, or you made a mistake in calculating the quotient. If this does not verify, you can go back and recheck your work. So you are not only going to tell your students some amazing method to handle problems, but you're also going to tell them how they can check their work and they can get good score. Okay. So moving on, I hope that's clear. So Bijank is basically digit sum, and the remainder theorem, we all know how this works in dividing any polynomial, dividing any number. So that is basic, that all mathematicians know. But the only new thing I'm introducing here, or maybe you know it already, Bijank method. I'm not saying I'm introducing, but I get to know and I'm sharing it with you. So the second example is again linear divisor, but here the leading coefficient is 2, if you notice. Correct? Leading coefficient is 2. How to handle this type of division? So here divisor we know is 2x minus 4. We need to get modified divisor. So that we can get by the ultimate goal is here to make the leading coefficient 1. So that means to make the coefficient of x1, that we can only make by taking 2 as a common factor. So that's why this is called modified divisor. Now, modified divisor is x minus 2. So you took the deviation, which is minus 2, and you took its opposite, which is positive 2. So we do the same thing. We copy down the coefficients in the descending exponents of x. Same thing, linear. So we have a demarcation after the last digit, one last digit, and then we will do the division. So this process is the same. 3 as it is, you multiply these two, you get 6, you add these, you multiply these two, you get 4, you add these, same thing, you multiply these, you get this, you add these. The step is the same. The only difference would be in one step when the linear divisor is there, but the leading coefficient is not 1. So what we have gotten, 3x squared plus 2x plus 9 as our modified quotient. Why did I use modified quotient term? Because I use the modified divisor here. This was the divisor I used. I did not use the original divisor. So that's why I'm writing it as modified quotient. Now, don't forget that there was 2 here, which we missed, which we did not take in the beginning. So that means we have already taken 2 extra. So we need to divide this quotient by 2, and whatever you will get will be your final quotient. So 3 by 2 plus 2 by 2 is 1, 9 by 2. The remainder stays as it is. You do not divide remainder by this. The only thing you will divide will be the quotient. And since you are all mathematicians, you have been handling math, so I will go in reverse. So even with when you let's say you come across when you are introducing the concept of dividing numbers to your students, even there you can use this method and you can apply it. So your 4th, 5th grader would also know how to divide by Paravartya Yojita, not they have to wait to know algebra and apply this method. And I will share you the book I like the most, which was the first book, which was published on Vedic mathematics, written by, on the base of the Swami Bharti Tirathji's diary by his disciple. And, there are 40 chapters, there are 78, 79 topics on that. And I call it Ocean of Knowledge. You just need to take a dip and you need to take the pearl out. So this was the second example. Sir, am I taking too long?
No. Yes, you can finish within 1 or 2 minutes.
Okay, so I will just quickly take the next problem and then I will finish it. Sure, sir. Okay, so then the next is if you have a quadratic divisor. This problem is if you have a quadratic divisor. So how to handle those problems? So since it is quadratic, the degree is 2. So we will start from the extreme right and we will have the demarcation from the last 2 digits. If you see, my demarcation is already here. So what is the deviation here? Deviation here is positive 2 and negative 15. You see it here? We are not taking zeros. We are taking deviation here is positive 2 and negative 15. Transpose, we will take opposite, negative 2, positive 15. And then we will divide like that. Now we have 2 numbers. So you will, at that same time, you will have 2 digits under the 2 rows together. So as we are in short of time, so I will be just quickly showing you, how we get the answer, and then probably maybe next time or maybe some other time, you can get to know about it. So this is how you get when you multiply with the first digit. You will copy the numbers down under the next 2 columns, and that's how you get your quotient and remainder. Same thing, you can check it with your Bijank method. Then the last example I've taken here is, again, the divisor is quadratic and the leading coefficient is not 1. In that case, you again have to do the same way as I've shown you when we took the linear polynomial with leading coefficient not 1. So the basic is the same. So you will have the modified divisor. You will note down the deviation and its transpose. You will divide, and then you will get the modified quotient. So don't forget to divide with the number which you have taken common, and then that's how you will get your actual quotient and the remainder. So that was all with the thinking. This is my motto for today. With you all, Sahviryam Karvavahe. May we all work together with great energy and take this wonderful field of mathematics forward and create something new, make our students interesting in learning this mathematics. thank you all for giving your time to me and for listening to me. Thank you.
Thank you, Nandita ji. Thank you very much. Yes, anybody, any question? Yes, anybody want to ask a question?
No, sir.
सर बुक का नेम बता दें जो ओशियन ऑफ नॉलेज मैम ने कहा है.
जी जी.
Okay,
Ma'am, you are muted. Kindly unmute yourself.
Oh, sure. Thank you. So, whosoever has asked, that is my personal opinion. I like it very much. So, let me see if I can share the title page.
Ma'am, you are muted, please.
I guess somebody else is muting me because I've been muted myself many times. So, okay, am I audible now?
Yes.
Oh, okay, so it is Vedic mathematics, 16 simple mathematic formulas from Vedas, and by Swami Sri Bharti Krishna Tirth Ji Maharaj. That is my personal favorite book. You might find some, discrepancy because that was the first edition, but then you can dig into it and find it. I'm not sure, Nimala ji, I just got it. Maybe in India you will get it and you'll get to know. And I also would like to mention there are so many books out there. I personally like Rakesh ji's authored books to start with your students. Definitely look at that. And I think he can share more information. There is Dr. S.K. Kapoor, who has worked a lot in this field, and there are many more. This is just to name a few. This is what I came across.
Yes, Nirma ji, we will share you the books, and we have online this book, and we will send you copy. Okay. We will send you this copy in the group. Okay. Are you in the group?
Sorry. Yeah. So if you have anything to share, any, you want to ask or you want to share your experience, please feel free to share. Okay. Thank you all. Thank you.
Thank you, Nandita ji. Thank you. आपसे all teachers are satisfied and nothing is to ask from you. Okay. And मैं अब लास्ट में डॉक्टर सुनील बजाज हमारे साथ जुड़े हुए हैं. मैं उनसे कहूँगा कि हमारे इस इंटरनेशनल जो रिसोर्स पर्सन हैं प्रोफेसर नंदिता गोयल जी, उनका धन्यवाद दें, थैंक्स करें.
Some of the participants raised hand. Menka Sharma raised hand. Please ask anything you want to ask.
Yes.
हेलो, गुड इवनिंग सर.
हाँ, गुड इवनिंग बोलिए.
सर, हमें टेक्निकल प्रॉब्लम थोड़ी सी हो रही है इसमें वीडियो को देखते हुए. जब भी हम अपना ये नेट प्रॉब्लम हो जाती है तो हमारा कनेक्टिविटी डाउन चली जाती है. तो जैसे ही हम वापस इस पे आते हैं वीडियो पे, तो पार्टिसिपेंट्स में हमारा अपना नाम नहीं आता, बिटिया का नाम आ जाता है. तो बार बार मुझे री ऐड करना पड़ता है वो. तो ऐसा कुछ सर, इससे मुझे कोई प्रॉब्लम तो नहीं आएगी? नहीं,
कोई प्रॉब्लम नहीं है, अभी बाद में करेंगे.
हाँ जी, कभी ऐसा हो कि मेरी एब्सेंट लग जाए.
नो प्रॉब्लम. ये तो हम जो है डिस्कस करेंगे, कल डिस्कस कर लेंगे, मंडे को डिस्कस करेंगे भी. ओके, वी विल डिस्कस इट ऑन मंडे. अभी जो नंदिता जी ने जो भी डिस्कस किया है, इफ you want to discuss related to this content, then discuss it. Okay.
So I think the participants have enjoyed this session. Actually, very lively. It was very lively, organized, and very well, nicely presented by Dr. Nandita, and very nice pace she adopted. And I'm also very impressed that she handled the situation and handled the interaction very well, and all the participants enjoyed, and even the things how the Vedic mathematics is dealt in US, how the schools are promoting it, how other peoples are promoting, how researchers are working on it. So taking into this into consideration, I think our participants are motivated, and on behalf of all participants, because this is 100 participants have joined through Zoom, but there was live streaming on YouTube also. So many teachers might have joined. I will come to know the actual data from the host later on. But I am thanking once again to the Dr. Nandita Goyal, who took her precious time and discussed this Vedic mathematics with the teachers, as well as and helped our teachers to learn more about mathematics. They are motivated. They came to know that this is not only for calculation, it can be used for in general mathematics also. They can learn the concepts also, and she gave some of the examples also. So once again, on behalf of SCRT, Director SCRT, and the participant, I am very much thankful to Dr. Nandita. Thank you once again. And thank you all.
थैंक यू डॉक्टर साहब, आपने जो है इनका धन्यवाद किया, हम आपका धन्यवाद करते हैं कि आप जुड़े हैं हमारे साथ. एंड थैंक्स अ लॉट टू यू नंदिता जी, एंड थैंक्स टू ऑल द पार्टिसिपेंट्स. इतना अच्छा वे से आपने मैटर कंटेंट रखा, और हम सभी की ओर से, सभी पार्टिसिपेंट्स की ओर से हम आपका बहुत बहुत आभार व्यक्त करते हैं. थैंक यू वेरी मच. थैंक यू टू ऑल. नाउ टेक रेस्ट, एंड on Monday we see you again. Okay, tomorrow on Sunday there will be holiday, so on Monday we see you again. Okay, thank you very much. Thank you to all.
सर
Yes. Yes.
सर लास्ट 2 टॉपिक्स दोबारा मिल जाएंगे सर ये मंडे को, क्योंकि नेटवर्क प्रॉब्लम था, हमें कुछ नहीं समझ में आया.
ये आपको रिकॉर्डेड है, ये YouTube चैनल पर है, ये we will send you, हम भेज देंगे आपको. राइट?
ओके, थैंक यू सर.
Yes. Okay. And all participants are informed to write this write-up on the lecture of Professor Nandita Goyal. आप इसके ऊपर राइटअप लिखेंगे सभी, और मेरी ईमेल पर आपको सेंड करना, जो इन्होंने आज बताया है, सभी ने उसको राइटअप में लिखना है. थैंक यू टू ऑल. थैंक यू वेरी मच.
Thank you everyone. Namaste.
नमस्ते सबको. नमस्ते.